A nut is opened by a wrench of length 25 centimeter. If the least force required is 10 Newton, find the moment of force needed to turn the nut. So we just need to apply the formula torque is equal to force and the distance from the pivot. So here I have drawn 25 centimeter. I have converted it in meters, 0.25 meters and 10. So multiplicating them, we will get 2.5 Newton meter. Let's go for the next numerical. A wheel of diameter 2 meter is shown in figure with axle at O. O is the axle here. A force of F is equal to 2 Newton is applied at B in the direction shown in figure. So here's a force which is applied at point B. Calculate the moment of force about the center O, about if we think this as a fixed center O. And second, they have asked about point A. So if this is fixed, then what will be the moment? So what will happen in this case? We have to take the force is same, but the distances are different. So first, that torque about center will be of this much distance, and for the second one, we have to consider this entire diameter. So let's see the solution. So here, in the first case, the perpendicular distance will be this length. So that's why we will half it because its diameter is 2 meters. So the radius will be of 1 meter. So 2 meter by 2 will be 1 meter. Then we will calculate the displacement as a torque as force into displacement 2 into 1, 2 Newton meter, and it will be in clockwise direction. So if you can see from the diagram, it will be on this direction. It will be rotating like this, right? So it will be a clockwise direction. Now let's see the second case here on the right. Now if this is pivoted, then we have to take the entire distance from here till here. So that will be the perpendicular distance, and then we will calculate as 4 Newton meter clockwise. So of course that because distance has increased, if this point is pivoted, then the torque will also will increase. It was 2 Newton meter, but now it is in the case of A, it is coming as 4 Newton meter. The direction will be, of course, on the clockwise direction because it will tend to rotate in this direction. Let's go for the third. A 50 kg mass is being lifted by using a 1 meter long lever. If the length of the lever is reduced by 20%, so we have reduced it by 20%, how much more or less force is to be applied to achieve the same torque? How much force we need to apply? First thing is it should be less or it should be more. See, we are reducing the distance and we want the same torque. So if we are reducing the distance, we have to increase the force to get the same applied torque. So torque formula is force into displacement. So if this is constant, this torque is constant, and if we are decreasing the displacement, the force has to be increased. So let's see how we can solve it. So here it was the case like this 1 meter, and now we have reduced by 20%. So 1 meter 20% is 0.2 meter reduction. So it will be 0.8, and F, the new force which we need to apply multiplied by this distance has to equal the moment which you were getting before, and that was we were picking up the load 50 kilogram force with 1 meter distance from the pivot. So we will equate this, and solving this we will get 62.5 kilogram force. So this we will get. Now we can convert this kilogram force into newtons by multiplying it by g here. So g is acceleration due to gravity. I have taken it 10. So 62.5 into 10 will be 625 Newton. So we have to apply more force. If you see, the previous force was 50 kilogram force. If we consider g in that case also, it will be come as 500 Newton. And now we have to apply 625 Newton. So the answer is 125 Newton more force we need to apply. I have assumed G is equal to 10. In your textbook, they have assumed 9.8. So the answer will be a little lesser than this, 122.5 Newton, I guess. Let's go to the next. So a mechanic applies a force of 100 Newton at the end of a spanner to tighten a bolt. The length of the spanner is half a meter. How much torque is exerted on the bolt? So first we need to apply just formula. If the mechanic increases the force applied by 20% but holds the spanner closer at zero point 0.4 meters, would it result in an increase or decrease of torque? Because see, we are playing with both things. We are increasing the force, but we are decreasing the distance. So we have to calculate whether we are getting more torque or not. First, let's calculate what is the torque. So torque will be force into displacement. We were applying 100 Newton and with a half a meter distance. So we will multiply that and we'll get 50 Newton meter. So this is the torque which we were getting. Now let's bring the changes. Now, if the mechanic increases force by 20%, so now think about percentages in terms of fraction. So 20% is nothing but 20 by 100 or 0.2. So we are increasing by 20%. So what does that mean? 100 Newton will be multiplied by 1.2. So 120 Newton is 20% increase from the 100 Newton. So just understand like how to deal with the percentage here. So to increase 20%, I have to increase multiplied by 1.2 to get the final value. So 120 Newton now we are applying the force. Distance also has changed. Now it is 0.4. It was 0.5 before. Now it is 0.4. We have reduced it. So let us calculate 120 into 0.4 is 48 Newton meter. Now see here, before we were getting 50, but now with these changes we are getting 48. So the decrease, there is a decrease in the torque. How much? 50 minus 48 is equal to 2 Newton meter of decrease. So we are decreasing the torque doing this arrangement by 2 Newton meter. Let's go to the next question. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of the magnitude 6 Newton. Draw a diagram to show the application of forces and calculate the moment of force applied. So this is the by circle, by drawing a circle, I'm showing a steering wheel, and here is a diameter I'm showing 0.5 meter. And here is the application of forces. We have to be careful about the forces because if I'll put in this direction, then only I will get the anti-clockwise movement. See, that wheel should rotate like this, right? If I put this force downwards and this force upwards, then the wheel will start rotating in clockwise direction. Right? So remember, they are asked us to draw the diagram according to this. It should be anti-clockwise rotation. So I will apply force like these. So now they are equal, opposite, parallel forces. So we, in this case, is of a couple. In case of couple, torque is just a force into d, where d is the perpendicular distance between line of forces. It is not the distance from the pivot. Remember that that is a difference when we are working with couples. Here is a couple, so we will take entire distance between these forces. This and this force between distance is 0.5 meter. So 6 Newton force we have to take for calculating this force. We can take either force, so we will take the magnitude of this force like 6 into 0.5, it will be just half of 6 or 3 Newton meter.